Oh, Dan. Hey, hi.
How you doing, Sandy? Good to see you.
Lurking in back of my truck here.
Yeah. Welcome to the Three-Dimensional Services Group.
Thank you so much. Thank you. Yeah, luckily you're doing your parking lot, and I got a chance to park right out here.
Right in front of the sign. We like it.
How did you do that? Yeah, you guys plan, I guess. You're planning. That's good. So that's the prototype area, right?
Yeah. Well, this is actually our headquarters. This is where the Three-Dimensional Services Group was really founded. Three-Dimensional Services Group was founded by Douglas Peterson in 1992. Since then, we've grown across Southeast Michigan to over 500,000 square feet of manufacturing space.
Wow.
So we're in the prototype and low volume manufacturing business. We work with truly innovative customers to validate their designs, and then we're able to scale those up across a massive amount of equipment to support volumes that a traditional prototype shop could never support.
Wow. Well, I'm excited. So we're starting here, and then we're going to take a tour around.
Yep, you're going to see both of our campuses, both here in Rochester Hills and then our main metal forming facilities up in Lapeer, and we're excited to show you everything we're doing here.
Cool. Let's get going.
Cool. Awesome.
Good. Thank you. Okay. Okay, so Shane is in charge of bits and pieces and making all this stuff kind of come together. So Shane, why don't you describe a little bit about what's going on here with these seats?
So this is an entire second and third row seating program that we did back in 2013. The unique part about this is that Three-Dimensional has the capability from CAD file to finished product to do all of this in-house. So we are receiving the files, we're designing the tools, we're CNC cutting the tools, we're stamping the parts, we're robotically spot welding, we're laser welding, and putting this entire thing together. So you're looking at a program that has about 1,200 part numbers that was done in about 8 weeks, start to finish. So customers...
Wait a minute, 1,200 part numbers on here?
Yeah, between all the fasteners, rivets, stampings. Yeah, it was a massive undertaking.
Wow.
So even like, Sandy, these are all custom, which is, you'd think at this point that there would be like fasteners that would be just off the shelf items, but these are all custom fasteners that we had to make. Again, the only thing that's being supplied to us on a program like this are the mechs. So you're looking at like the tracks, the recliners, the actuators, motors, everything else Three-Dimensional does in-house. Even the spring wire and the flex mat and the overmolding, all done at Three-Dimensional.
You know, I get around. I know a lot about prototype houses and stuff, but I don't know of anybody, at least I can't think of anybody that could take on that much. That's vertically integrated, and most people will be farming this out, farming that out, and you do everything here.
Yep. So that's one of the things that like we pride ourselves on is our program management as well. Because that's half the challenge is just manufacturing the parts. The other challenge is managing something this large. So
managing it that quickly.
Yeah.
8 weeks is nothing. I got to tell you.
So when you're looking like this program, you can see like this has just regular metal stamping. It has CNC tube bending. It has springs in here. It has injection molding and overmolding. It has torsion rods. It has just wire bends right here. So there's really every facet. And in my head, seating is the most complex thing to manage and to manufacture because everything's got to work perfect. Like the kinematics need to be perfect. So after we weld this whole thing together and bolt it together, we need to function check it. So we need to make sure that like the travel's there, that it goes, all the way forward, all the way back. We measure the amperage on the motors. So like there's probably 100 checks that after the seat is done that we need to do to validate that it's going to meet the production requirements.
So one thing we should mention as well is that these things have been in the market for a long time.
Yeah, correct.
Great.
Yeah, so like again, this was a 2013 program. Here's some West Coast seating programs are. Like these go back to 2016, 2017. So they're already in production, which we're allowed to show at that point. But again, you can see this is a program with laser welding. You can see like the upper headrest to the back frame side members. And these are parts that are super complicated too. Like you're getting into advanced high strength materials and ultra high strength for the CAFE standards. You're trying to lower the weight of everything. So like these back frame side members, Sandy, like those are DP 980. Like absurdly difficult to form. And you need a lot of simulation in order to even achieve the tooling strategy to get these parts to work.
Yeah.
And you can see if you run your hand right here, there's a curl.
Yeah, I did.
Yeah, so that gets curled, that gets curled. So like
yeah, this is, and that's why I stuck my fingers in here. So when you look at a part like this, where it's dished out, it humps around, and then you got a return flange, that L-shaped flange. That's a really expensive, hard to do type of die.
Yeah. So even at a prototype and development stage, like this part right here requires like 8 different tool sets: punches, dies, curl flanges, secondary operations, and then restrikes. So when you're laser welding, everybody tries to achieve a 0.1 profile, which is near impossible. So you have restrikes on the laser weld area on the front and back right here, and then also on the areas right here and here.
Yeah. Okay, so for the viewing audience, why don't you describe or like explain what a restrike is, so you take the assembly and go ahead.
So a restrike operation is like you've already drawn the part or formed the part, and now you have some areas that will have spring back in them, or maybe the part is not as flat as you wanted it to be. So you're restriking certain areas. On this, it happens to be the upper headrest area and the lower cross member. And you're doing that to get almost a perfect flatness on here. So you can then laser weld this surface to this part right here and on the back side. Again, a laser weld, you're working with 0.1 profiles, so your part quality has to be superior. And the reason that they do that is once you achieve a part that's good enough to laser weld, the assembly operation itself is significantly faster than any other process that can be done for assembly.
Yeah.
So this is sort of like the evolution of three-dimensional, where we started off as a prototype company, but we have bridged the gap to now being a low volume production company and also a bridge production company. So when the production vendor doesn't have their tooling done on time, which is more often than not now, everyone's trying to compress delivery timelines and shorten it up. So we bridge that gap. And this happens to be one we ended up supplying parts for about 9 months, which was 100,000 pieces. But it's just an aluminum 3rd row back panel stamping. And the production supplier on this one happened to be having issues with the belt loops that go around the perimeter here on consistently getting those where they needed to be. So our customer was just like, we need one more month. That ended up being a significant time frame. But this again shows like our level of quality. We have attribute fixtures, so we run 100% of our parts over attribute fixtures. It's just a insurance policy for us that the parts are good.
Can I ask you a question? Okay, so everybody kind of knows I was a tool maker. Why did they have a problem with that belt loop? What was the reason, or what was, you know what it was?
Yeah, this was actually a material thickness issue. So going around in here, you had material thickness with a tolerance of like plus or minus 0.12. And the tool, for some reason at the production supplier, if the material was coming in on the high side, wouldn't properly put those in. So depending on batch of material, they were running into issues.
Okay, well, let's move on to these augers and stuff here.
So this just shows some of the diversity of the company. Again, you've looked at automotive parts, you've seen automotive seating. Now we're getting into like, we make parts for snow blowers and lawnmowers too.
Yeah.
So this is just interesting. Again, these guys, they actually go test these up in Nebraska in the middle of the winter. They're throwing snow in these. So there's like a shelf life on when they need their prototypes done. And again, they're always just boils down to timing. Like they have design done in like September. They need these parts manufactured in 6 weeks, assembled and shipped up so they can test them. But this is, again, just metal stamping. So you got a stamping here and here, another stamping right here, and then a deep draw. If you actually look at the cap on this, you have a deep draw stamping, and then you have the chute where the snow actually comes out of right through there as well.
Wow.
And then you have the augers that go in there. So these are made out of stainless, and then they get a coating on them. But again, you can see sort of the complexity going from different processing. So you have a robotic spot welded assembly to a robotic MIG welded assembly, and from regular steel to stainless steel. And then you have a really difficult stamping right here, where this is like a 42-inch lawnmower deck. So this right here is about 4 hits, Sandy.
That's me. I was just trying to calculate that out, and I was already at 5, and I wasn't done yet. So that's pretty good. So, and now we're at this this banjo axle here, and you did all of this as well?
Yeah, correct. So this one's pretty interesting in the fact that there are multiple different manufacturing processes being used. So this has stampings, this has forgings, it has casting, it has CNC turn parts, it has robotic MIG welding, and then even after this whole thing has been welded together and assembled, there is post-machining of the surface right here, and then also post-piercing of these features right here to hold tolerance. So you're looking at something that might take 5 or 6 other companies to do. 3Dimensional is capable of doing all of this in-house just with our vertical integration. When we're doing the development programs, we're not only proving out the stamping design, we're proving out the process. So we use the same amperage, voltage, the same weld wire, the same feeds and speeds as production. So when this transitions to me making 100 and it transitioned to production making 500,000 of these, we've proven out the warping of the part by following the same sequence. So there's a lot of value being gained in just the processing of what we're doing and then translating that to the production supplier.
Well, it's kind of amazing from my standpoint. I mean, like I said, as a kid, I did this kind of work with dies and molds and whatnot. Can we have a look at maybe some of the stuff that would, make this product?
Yeah. So as we walk around, we're going to look at some of the lasers, some of the stamping presses, some of the robotic MIG weld cells. Yeah, and we can actually dive into different processes that were used and filter back to how they were used on this assembly.
Perfect. Well, let's go and have a look. Yeah.
So this is what we call, we had named years and years ago as cell manufacturing. So each guy has his own work cell that he can run his jobs out of. So we have leaders that and mold makers that work with our designers on a tool design. They collaborate, they go over everything. They all have CAD stations that they can look at data and parts and kind of help design the tool that we need. They have a lot of experience, and it's really a good fit having the designers right here in the building with the mold makers to design the tool, let alone cutting the tools and manufacturing and things like that.
So each guy's got
each guy has his own Bridgeport, digital readout, all the bells and whistles that a mold maker would want. We really try to keep this type of equipment because it's not monitored by a computer and things like that, like a CNC machine to tell you when things are going bad. So the guys are all really tuned into, knowing their machine, knowing, if they have issues or problems going on. But they work with upgraders that help them out, squaring blocks up and drilling holes and things like that we're not doing on a CNC maybe, and they're the guys that are learning to be the next mold makers. We do a lot of that where we've got guys in training to kind of take over when guys retire and things like that.
So we used to call those improvers. But this, so I have one of these, older, and probably not as sophisticated. Yeah, not nearly as same brand though.
Yeah.
And my guys have no clue what the heck it is. So it doesn't have the little crank and whatnot. I have to bring it up and down manually. And there's a little micrometer adjustments on it so you can get just exactly. And this is where I excelled when I was a kid. I had really good eyes. I had a very good touch for, bumps and thicknesses and stuff like that. And so somebody saw me take it's a big wooden box, saw me take it out. Well, what the hell are you going to do with that? I said, well, I'm going to scribe some lines so we can cut this thing up and it'll be accurate. Well, how does it work? I couldn't believe it. Yeah, so anyways, this would just totally
it's
blow
a tool
their
that
mind.
these guys couldn't live without. They're real sticklers on tolerance. Tolerances in injection molding are very tight. We have very tight tolerances on the parts, so the tools have to be even better. So yeah, it's a carbide tip that's sharpened to basically a
Very
razor.
fine. Yeah, like a razor. Yep, there we go. Wow. Well, a lot of this looks the same.
Yeah,
Except
it's
my
very
toolbox was wood.
yeah. We also we do a lot of quick change molds as well. So in an injection mold, you either have to build the entire unit of the mold that houses the ejector system, the water, everything is contained in that mold base when you put it into the mold machine. Right. The way we do some of these molds is we actually machine and prep these blocks so that they're ready to go into the CNC mill. So they've already got the guide pin holes, they've got the corners labeled, they've got the ears on them, they're ready to slide because these are quick change. You can set a mold in 5 minutes with this system. So we literally have hundreds of these blocks already prepped on the shelf so that when we get a job, we don't have to order material, we don't have to wait for somebody to manufacture this block. We set up our pallet changing Makino mills and we make hundreds of these things when we're a little bit slow.
Pretty good. That's very good.
Thanks. So here you can see he's looking at CAD models of injection molds that we're making. So from this, they can double check, or if they're missing a dimension. We do a lot of it from 3D CAD versus making a detailed drawing for every component that we make. We'll do an overall drawing, but the rest of it, the guys all have CAD systems. We use PowerShape from Autodesk. We're trying to move into Fusion 360, which is their new product to take over for PowerShape. Used to be called Duct 5 back in 1960. So it's a very old system. But this is all rewrote, new software, but again, it's being superseded again in a couple of years here. So this is one of our horizontal boring mills. So these machines, we're doing a lot of prep work on our what we call freestand molds or dies. So we have to put in eye bolt holes, we have to put in clamp slots, we have to face the surface off so it's nice and smooth and flat so that it can be prepped to go on to another machine and actually do the finish cutting of the mold cavity or die, depending on what we're cutting. So in this facility, we cut both. We cut injection molds. We also cut stamping dies for our stamping plants.
So I would like to mention one thing. Okay, so you see these L brackets?
Yes.
And these gauge blocks. When I was a tool maker, or when I was an apprentice, this is the very first thing they give you after a file.
Right.
They give you the opportunity to make perfectly square, perfectly sized gauge blocks. And guess what? It's a bugger. Because the piece of steel they give you is all chewed up and horrible, and they throw it at you and they say, go make a 1, 2, 3 block.
Right.
That's what that is.
I made a set of 1, 2, 3 blocks in 11th grade in 1985. that I still have today.
And mine were stolen just a while ago. I couldn't believe it.
So these are our machining centers for graphite. So we cut a lot of graphite, which is a carbon material that we use for EDM, electrical discharge machining.
Easy for you to say.
So we use a very similar system like FCS we were talking about on the mills. We use a system from Aroa to locate these parts very precisionally. So there's a receiver in here, and then we have that hooked to an Aroa robot that feeds the electrode blanks into the machine and takes them out. It loads the programs, it kicks the machine off with cycle start, finishes it, takes the part out, puts the next one in, and continues to do that. So it's got a pretty sophisticated software management system to run not just the mills, but the EDM machines too. So those are all connected together. They all of the electrodes have a place for a chip to go on them. So once they're actually put into the machine, they have a chip on them because the robot uses that to read. These would be examples of finished electrodes. So these are things that aren't real practical to machine on the mill because they're so, those ribs are so thin. Getting a cutter that deep, that's that small, it's just impractical. It takes too long. Typically, you don't get the best finish and things like that when you're trying to do a lot more than your cutter can handle. So we change that over to a male feature, and then that goes into the EDM machine to burn that into the workpiece.
So what's the life expectancy of something like that?
So this, we need anywhere from 2 to 3 electrodes for every burn that we do. So the first one that goes in there is our roughing electrode, and it wears significantly, probably 50-50, let's say. And then we go to the next new electrode, and that burns a little bit more out. And sometimes that can be the final one. Sometimes we have to add a third depending on how precise it needs to be. Maybe has a really thin feature, things like that, where the electrode might wear a little bit quicker. These are all predefined electrodes. We have libraries of electrodes. We purchase these blanks already squared up, or they're saw cut. They're saw cut, but they have threaded holes in the bottom of them. That's how we take them in. Each one has a part number. It's in our library, in our CAD system, and we can choose that stuff very easily. And then all those electrodes are sitting on the shelf, the blanks waiting, just same as we do our mold bases. So we're not waiting on anything to start a job. So the robot holds electrodes in all these magazines.
Wow.
So it holds on both sides. So this will hold 128 electrodes, I believe, between both sides of the rack. So it can run for a very long time without being attended to. The other thing is the tooling on this machine. So it's a little bit different than a cutter we would use on a milling machine. So obviously we've got your typical.
Oh, drill looks the same.
I mean, this one's kind of similar. Okay, so you got a regular cutter with flutes on it. That's your typical end mill. So you can see this is more of a
grinding. It looks like a rasp around a rat tail rasp.
And then this is coated with a grown diamond on top of it. So, the tools are 10, 15 times more expensive because of the diamond coating. But they last so much longer. You're not stopping your process to change tooling. They last a very long time. So both of the machines that are hooked to this robot have the exact same tooling in them, the same holders, the same lengths, so that the guys are always they're machining with what's in there. It's the same every time, and it works great with a robot setup because obviously you got to have consistency. We can't be changing out tooling every time. So these are great examples of features that you could not machine into a tool. So this is a very thin rib. Okay. You can kind of see the outline of the part on there.
Yeah. Oh, I see.
So these are just standing features that are in the mold.
Yeah.
That are wearing on the side of this electrode, and you can kind of feel a little bit of wear on there. It's not much. It's a very light amount that it's worn. Same with this. There's no way you're ever going to machine a 3-inch tall rib that's only, you know,
No.
a millimeter, a little over a millimeter wide. So again, same system on the EDM machines. We have the chucks that hold the same fixturing that we're using for machining. So we just transfer from the robot to the EDM machine. And you can see here we have so this is an injection mold tool that we're putting a lot of ribs in. You can see all the cross lines in it. Some of those cannot be machined, so that we then have to put an electrode in and EDM that feature into the part. So this is the green oil is a dielectric oil. It keeps it's a non-flammable oil, so it's a lot safer to work with when you're putting a spark inside the oil. All right, so in this facility we do our injection molding of parts. So we have 26 injection mold machines that range from 30 tons to 1,500 tons.
Yeah.
So we can do some very small components to door panels and very large components.
Well, you got quite a display area here.
Started buying these machines, and we bought about half a dozen the first round and just fell in love with them. They're really, really good machines. The guys like them. We're making better parts, so it just made sense to get rid of our old equipment and not only add, replace it, but then add, probably another 40% on top of what we had for new machines. So
what
majority of these are horizontal injection mold machines. So you've got your hopper where you feed the plastic in, plastic pellets. That goes into the screw in the barrel, and then that's pushed into the cavity of the part.
Okay, so Dan, I can see that we're moving pieces over here, and we're standing in front of some sort of a 3-axis welding system or whatever.
It's a cutting system.
It's a cutting system.
Yes, so this is our Trump True Store system. We've got a twin tower feeding a butterfly configuration. Two 50, 40, 12 kilowatt 2D lasers are running off of this automation system, allowing us to keep these lasers running as efficiently as possible. The speed of these lasers when we get up to the power that we currently have absolutely necessitates this automation, allowing us to keep the laser running as often as possible.
It's funny. Well, not really funny, but to me it's very interesting. You have a pre-production facility that I'm sure pretty much everybody would die to have. I'm surprised that you may be the biggest in the world right now, but I'm surprised you're not twice as big, because everything you're doing here is things that OEMs and Tier 1s should be doing.
Absolutely.
And I've seen progress slow right down with other companies, with bigger OEMs of any type, whether it's aerospace or appliances, whatever. They always slow down because they try and do it internally. This is the best thing as far as I'm concerned. And looking at what you've got going on here, it seems to me that if I was in that kind of a situation, that's what I'd want from you. So that's my assessment of everything I'm seeing here today.
Yeah, we appreciate that. And we want to work with the world's most innovative companies. We want to work with the companies that want to go fast and really change the world. We are a job shop. All of the capabilities that everybody's seen here are available to anybody that wants them. It's as simple as just sending us your data and getting a project started. Sandy, this is one of our 2D laser cutting systems. This is a Trump 5040 2D laser cutting system attached to a twin tower True Store automation system. 12 kilowatts of power, does all of our flat sheet cutting. Yeah, so we can cut steel at just under 1,300 inches a minute. We can cut stainless steel at just under 1,600 inches a minute. And we're going to cut aluminum at just over 300 inches a minute. So this is really interesting Trump technology. We've got a couple examples of what are called micro joints. and then nano joints over here. These allow us to keep the parts in the skeleton while it's being cut without the parts falling into the scrap conveyor. So the micro joints have a full thickness joint that needs to be deburred, but it keeps the part in the skeleton. Trumpf has this new technology called a nano joint that allows these to have virtually no burr on them whatsoever. So only a very, very minuscule portion of the joint is left on the part. We do that by powering it down, and then these are very easily removed with no deburring required.
Wow.
As opposed to other processes that would certainly require the deburring. Anything we can do to improve efficiency in a manner like that, we're excited to do.
Well, that is way cool.
Yeah, we're making literally over 3 million parts a year. Almost all of them require a blank developed of some nature. Anytime we can create efficiency, it's a massive plus for us. So you'll see some mechanical presses over here. The majority of our presses are going to be hydraulic. We certainly do utilize mechanicals when the application necessitates them. So metal stamping is the core of our business, and this press right here is one of the larger beds we have. This is a 1,500 ton press. It's one of 127 presses that we have company-wide. They've all got a variety of configurations allowing us to take on a variety of jobs. But really, this is the core of our business. We are vertically integrated from a tool design perspective, run all our own parts, and then laser cut them as well. So this is all handled in-house, vertically integrated at a significant scale.
So how many presses do you have then?
127 presses ranging from 20 tons to 5,000 tons.
5,000, really? What do you do on a 5,000 ton press?
Tubular hydroforming.
Oh, hydroforming. Oh, okay, good. Okay, so we're moved over here and we're now standing in front of a Trumpf 7040 Trumpf laser, and we're going to hear a little bit about its capabilities. It's got 5 axes, did you say?
Yeah, this is a 5-axis laser. We've got 25 Trumpf 5-axis systems company-wide. This particular version is a 6 kilowatt machine. These are the finest 5-axis laser cutting machines available on the market. Yeah, so this is really the top of the line Trumpf equipment. Its software is integrated with our 2D lasers, allowing for us to cut blanks and instantly bring them over here and bend a perfect part repeatedly. We're going to be able to produce very, very precision parts very quickly at a significant scale with this sort of equipment. And we're very grateful to our partners at Trumpf that have given us this equipment to use here.
Okay, so Shane, what are we looking at here? This looks like a seat bottom to me, but why don't you explain what's happening?
Yeah, so what's going on right here is actually, we're looking at a seat back. You got some recliners right there. So this is sort of like everything coming together at 3-dimensional. So we have already manufactured all the component level parts in-house. Then we get to the point we're developing out the fixture strategy. So you can see here we have an aluminum fixture, we have adjustable NAMS blocks, we have everything located on here to try to just, again, make consistent quality parts. The aluminum is used because it helps draw the heat out faster than like a steel would. So we're following all the production weld sequences, all the parameters, trying to prove out the process here. And you can see we got a robot over here and a robot over here that both have access to these fixtures that are on the trunnion. So part of this is for maximizing the output with the cell setup, and it's also maximizing the quality of welds we can put on with this being on a trunnion system right here. You can see this orange frame that wraps around. So this twists around. The whole reason for that is to avoid doing any vertical welds. Obviously, that's worst case scenario for a weld when you're looking at it. This particular program, we're running 150 sets of seats, but we're also running second row, third row. So the quantities add up. So this round will be 150. We already have expectation of a design change and another 150 sets of seats after that.
So based on what I've seen, you guys don't often go into production, but when the volume is low, you can make basically prototype parts, which would be at a low production level. Is that?
Exactly. So I would say, Sandy, you're looking at like 75% of what we do is purely development. Like the first couple builds, total of 300 parts would be a normal order. The 25% beyond that is the bridge production, the low volume production that can go from quantities anywhere up to, most of them are going to say 10 to 20,000 for those new niche vehicles, all the way up to the bridge volumes of a couple 100,000, just depending on what the urgency or when the production tools will be ready. Again, I said like we're like a regular company on steroids. Like this goes into like, we have over 100 stamping presses. We have over 75 CNC machines. We have, just for robotic MIG welding, we have 47 robotic MIG weld stations. We have 20 robotic spot weld stations. We have 6 different laser weld stations. So this is just like, again, a horsepower thing. Like an average company might have 10 presses. We have 100. We're up to over 40 5-axis laser systems. So like you combine all of that, and that's the horsepower to drive a program that quickly. And it just, again, other companies don't have the capability, the equipment, the manpower, the will to do those things.
So anyway, Dave and I are in front of a very large, what they call horizontal mill. And usually if I was in if I saw a machine this size and I was at something like a Boeing or an Airbus, we would call that a spar mill. They make them bigger than this, but this is pretty big to start with. And Dave, it's all yours. Okay. Tell me everything I need to know.
This is one of our new aerospace mills. So we're machining a lot of aluminum, very fast. These machines are 150 horsepower. We can take a 2-inch cutter, 3/4 of an inch deep, and go like hell. 50, 60 meters a minute. It moves a lot of material. We can fill up a 55-gallon drum of chips in 1 minute. That's how much material removal this machine will do. So it's a 2-pallet machine. So there's a pallet inside with parts cutting right now, and then you have the pallet on the outside of the machine that flips down to where the guys can change parts easily. The brand new technology as far as control too. So this is a new Siemens numeric controller. Very, very high-tech stuff they've got going on here. I've been machining since 1985, and I've never. And we have 88 mills, right? So I've done a lot of different equipment that I've worked on and gone through and set up and got them running, all that good stuff. This machine is so fast, it blows you away. It is something else compared to everybody else. Everybody else is putting out 30, 60 horsepower spindles. You just can't do the metal removal you can do on this machine. It's pretty amazing.
So what's the RPMs? The
30,000 RPM.
30,000. So
30,
it's truly
RPM.
a high-speed mill.
Yeah.
Yeah. So I have a question for you, based on all that. What do you do with all them chips? Because I know at Boeing, when they got the big machines, the biggest problem we had was chips.
So what we have is we have a chip conveyor on the end, which right now is just being dumped into a bin that we have to change.
That's a really small one.
Yes, we have the briquette system coming in from Rough, which is going to attach right to the machine, and it's going to brick parts right there. So we won't have as much volume of material because we can compress that material into pucks and then send that back to refining and whatnot. So this is our brand new Sterig Echo Speed 1540. So 1.5 meters by 4 meters of travel. Very similar to the Bavius as far as the work envelope and things like that. They handle their pallets a lot different than Bavius does. And then they have this spindle, which is mounted to a head called a Z3 head. This head, your typical 5-axis mill will either have a fork type head that swings, you have ABC axis, all those things, Or you have a machine like this that has 3 motors that pivot the spindle up to 45 degrees in any direction at any time. So it's a very fluid motion when you're 5-axis cutting. You'll always notice the fork head types have to unwind and they roll around, they do all kinds of extra stuff. This stays in the cut, and as it pivots around from the motor shifting it, it contours and we can cut up to a 45-degree angle. We do have 90-degree heads when we have to put in weeping holes and things like that. They run right through the tool changer, so it's all automated. And it's a spectacular machine. This one here is 120 kilowatt, which is right around 150 horsepower, I believe.
And that's for all 3 motors?
What's that?
You said
the spindle
that's just
motor.
for the
Itself,
spindle motor.
Yeah. Same type of parts, mainly designed to cut aluminum. Aluminum very fast. These 2 machines are neck and neck. We're cutting the same parts on both machines, and they're both right there and cutting the parts. And off of our fastest machine that we had before, which was a 60 meter per minute machine, which is really fast. This machine is twice as fast.
So has it got the same spindle speed as the other one?
Yeah, they're both 30,000 RPM spindles.
So why is this one so much bigger than that one?
Because they put the pallet at the end of the machine instead of in front of the machine. So it's not as deep this direction, okay? But in the way they do their head, it kind of has
longer
to,
instead of deep.
kind of would have to be, I guess the pallet change, maybe they could have done something on the back side of it. But it actually travels out and then flips around up top. So to load this machine, we have to go up the stairs, up top there, use the crane to load anything that's going onto the machine from up there. And that's where your second pallet is. So we run first op on one pallet, second op on the next pallet, and keep this thing going. Right now we can run about 18 hours unattended before we need to start changing parts. So we can hold quite a few parts.
Wow. That's 18 hours. That's pretty good. That's really good, actually. So I'm going to do a quick wrap up. This was a phenomenal trip for me. And the reason for that is because I came in expecting something, because I have been here before, and I wound up with a whole bunch of new things. And right at the top of the heap, hasn't got something to do with the parts that you're making or the equipment that you've got, the unbelievable equipment that you've got. It's actually, this is the first time I think you've ever told me about the fact of how fast you can bring products and get them into the customer's hand. I'm still blown away by that. I have no clue. I do know how you do it. You've got a coordinated machine of a company, and you've got everything at your disposal. So for me, that's my biggest takeaway. For the folks that are out there that are going to be looking at this as a should we use these guys kind of thing, you'll be more impressed with the fact that you can do these things in 6 to 8 weeks, and the great big giant jobs, well, in 10 or 12 weeks. That's totally amazing. So I'd like to thank you guys for giving me this tour, and this should be something where a lot of people on YouTube are going to be interested. So anyway, is there any kind of like wrap-up comments you guys want to make?
Really, we'd just like to thank you for coming out here. It was our pleasure to have you again.
Great, thank you so much.
Sandy.
Yeah,
Good to see you as always.
You're a great friend of Three Dimensional Services Group, and anybody that's watching out there, feel free to go to 3dimensional.com. You can learn more about what we do, get in touch, and hopefully we can work with everybody that's got a project that needs to be done.
and that says it all. So anyways, thanks very much, ladies and gentlemen.